This is another example of definite integration. This time we want to calculate the area between two vertical lines and two curves. In this example, it asks you calculate the area enclosed by the curves x equal 2, x equal 4, y equal x squared, and y equal x cubed. Now, I had plotted the curves with GeoGebra. You have these two lines, the two vertical lines. This one here is x. You have x equal 2, x equal 4. The blue curve is x cubed, and the red curve is x squared. So the area that you really would be calculating would be below the blue line, above the red line, right within this region, and between the two black lines, right? So you'll see, it's good to know or have an idea what the area looks like by sketching it. Here I plotted it, but you don't necessarily have to even know exactly what the area is, but mentally it helps you, alright? If you can just sketch it so you see what it is you're doing. You can see that the x cube line is steeper than the x squared line. So basically, you would have the two vertical lines, x equal 2, x equal 4. You have the x squared and the x cube, and then the area you want is right between here. All right, so let's look at it. This is integral from 2 to 4 of, remember this is 2 and this is 4. Now you have the x cube curve. If you were to find the area under the x cube curve, and this was the x-axis, then you would be finding the whole area here. So let me just erase this and look at each area individually. So these would be the lines, and then you have the x-axis. This is x equal 2, x equal 4. You have x cube. All right. The area that you'll be finding is all of this area. So you could say this is the integral from 2 to 4 of x cubed dx. Now, what about the x squared? What happened to it? If you should now do this. So, in this case, you have the x equal 2, x equals 4, and you have x squared. Then if you should integrate and say integral from 2 to 4 of x squared dx, the area that you'll be finding is this area under here, right? You see that? Now, suppose you make both the x cube and x squared go together. What will happen? You have the 2 here and the 4 here. You have the x-axis. So you have 2, 4, and you have the x cube, and you have the x squared, the area that you'd be finding would be this, the difference between the area under the x cube and the area under the x squared. You see that? When you put both of them together, it's like the x squared would be here, and you would have this area under here, right? But if you take the x squared area from the total, then you have only this area under here dealing with. So you're looking at the difference between the two areas. So what you could do is say you're going to find the integral from 2 to 4 of x cubed minus x squared dx. Alright? Now, you could do it like this. Or you could find each integral and subtract them. So you'd have the integral from 2 to 4 of x cubed dx minus the integral from 2 to 4 of x squared dx. Now, here, let us do it this way. We're finding the integral from 2 to 4 of x cubed minus x squared dx, and see what will happen. Now this, let's start it out here, see what it would look like. The integral from 2 to 4 of x cubed minus x squared dx is equal to x cubed. When you integrate x cubed, it becomes x to the 4 over 4, minus, you integrate x squared, it becomes x cubed over 3, and you're going from 2 to 4. Alright? So, this is 4 raised to the power of 4 over 4 minus 4 raised to the power of 3 over 3 minus, and now you substitute 2. 2 raised to the power of 4 over 4 minus 2 raised to the power of 3 over 3. So you substitute for x. X is 4 over here, and then minus, and then x is 2 over here. Alright? Substitute. So, 4 to the power of 4 divided by 4. What is that equal to? Let's get our calculator. Just show our, oh, it's advanced mode that I want. Right. Advanced mode. But I don't think we really need advanced mode here. I don't think I need to widen the calculator here. Alright. Make the calculator more narrow. Have more space to work with. 4. What is the raised to the power of? Oh. The raised to the power of. Here. 4 raised to the power of 4 equals 256. Divide that by 4, you get 64. So this is 64 minus 4 to the power of 3 now over 3. So this is going to be 4 raised to the power of 3. You get that? Divide by 3 equal 21.3. 21 and 1/3. Alright, 21.3. I put a dot over the 3 because it goes on and on. Minus And then 2 to the power of 4. 2 2 is 4, 4 2 is 8, 8 2 is 16. It's 16. 16 over 4 is what? 16 over 4 is 4. Well, this is 4 minus 2 to the power of 3 is 8. 8 over 3. Alright? So, let's get back to our calculator and see what it says here. Let me get back to 21.333. So 64 minus 21 and 1/3 equal 42.6 and so on. This is really 42 and 2/3. 42.6. Sometimes a line is drawn over it, but let me put the dot. Minus. And then 4 minus 8/3. So we have 4 minus, open bracket, 8 over 3, close bracket, equal 1 and 1/3, 1.3. So it's 1.3. The 3 goes on and on. Alright. So, one more thing we have to do now is just this subtraction here. So 42.6 and the 6 goes on and on, minus 1.33333 and so on, equal 41 and 1/3, 41.3. 41.3 square units. Alright? So we have 41.3 square unit. Now, the other thing I'm saying, suppose we did each integral separately and subtract them. What would happen? We would have integral of x cubed is x to the 4 over 4, and we go from 2 to 4, minus integral of x squared is x cubed over 3, and we're going from 2 to 4. So this would be 4 to the 4th over 4, right? 4 raised to the power of 4 divided by 4. 4 raised to the power of 4 equal, and that over 4 would give you 64. So we have 64. So, let's not jump to that so fast. We have to substitute 4 for x first. So it's 4 to the 4 over 4 minus then 2 for x, 2 to the 4 over 4 minus, and this would be 4 to the cube, 4 to the 3, 4 to the power of 3 over 3 minus, then substitute 2, 2 to the power of 3 over 3. Let's see how similar it is to what we did before. So it's 4 to the 4 over 4 minus, it would have been this. Let's open the brackets to compare to what we had before. 4 to the 4 over 4 minus 2 to the 4 over 4. So this is what we did a while ago. Minus, open the brackets now, is going to be a negative 4 to the 3 over 3, and then a plus 2 to the 3 over 3. Right? So that's what we would have. So, we could just open the brackets like this, and we'd have 4 to the 4 over 4 minus, let's put the 4's together, 4 to the 3 over 3. and minus 2 to the 4 over 4 plus 2 to the 3 over 3, right? We have 4 to the 4 over 4 minus 4 to the 4 minus 4 to the 3 over 3. You see that it's 4 to the 4 over 4 minus 4 to the 3 over 3. It is 4 to the 4 over 4 minus 4 to the 3 over 3. We did this part already and we got 42.6. But anyway, let's redo everything from scratch. So, what would happen here? Let's get back to our calculator and see. 4 to the 4 over 4 is 64. Alright? Then 4 raised to the power of 3 equal over 3 with 64 over 3. And then the 4 to the power of 4 over 4 was 64. So 64 minus 21.3 is 42.6. 42.6. And the 6 repeats. 42.6, as we said before. Right? Minus. What about 2 to the 4 over 4 plus 2 to the 3 over 3? What will that give us? Let us see. We have minus 2 to the 4 over 4. 2 to the power of 4. Well, 2 to the 4 is 16. 16 over 4 is 4. So we know that this is 4. Plus 2 cubed is 8. 8 over 3. Right? So let's add them up. The 8 over 3 is what? Is the same as 3 points. 8 over 3 is the same as 3 and 2/3, you know. Right? The same as 3 and 2/3. But anyway, 42.6 repeated minus 4 is that, plus, let's say 8 over 3 in brackets equal, I get 41.3 repeated. The answer we get is 41.3 repeated. Was it the same answer as before? Right. 41.3 units squared. Now, remember, what I did was to sketch the graphs, just to get an idea what it is we're doing. But maybe in exam, you don't have time to be sketching the graph to see, unless you're not sure exactly what's going on. But in exam, you could just do the integral from 2 to 4 of x cubed dx. Then do the integral from 2 to 4 of x squared dx, and then subtract them quickly to get the answer. Alright? But remember, even though I said quickly, you have to show all working, all steps. Alright? So, any question, comments, and so on, you put it in the comment section. I will see you in the next video.